wastewater treatment. Water pollution is caused by domestic sewage and industrial wastes. Therefore, any abatement of water pollution depends mainly on the efficiency of wastewater treatments. It is obvious that non hazardous organic wastes from domestic sewage has to be treated separately from toxic industrial waste. The primary processes commonly used for the domestic sewage treatment are as illustrated in the figure. In the first stage, solid wastes are removed from water by screening and any scum is removed. It is followed by the settling of the sludge. In the second stage, the residual liquid is subjected to biological oxidation of soluble organic materials through a bed of microbes in activated sludge. Next, the solids are removed by sedimentation. The liquid effluent from such a treatment has a much lower organic load, which undergoes chlorination, and after chlorination is done to kill pathogenic microorganisms, and after chlorination it may be mixed directly in lakes and streams. In sewage treatment, disposal of sludge is one of the major problems. The sludge can be spread on soil or landfills, though the landfills are becoming very scarce since the population keeps on increasing. However, for those localities which are near the shore, the sludge is usually dumped into the ocean, which has a fragile ecosystem. Or the sludge may be utilized as a fertilizer on croplands. However, there is one problem in this process. The presence of toxic materials in the sludge is a problem. There are also practices of incineration or pyrolysis of sludge, but again there is risk of contamination of air with the toxic pollutants emitted from the sludge. A safer procedure is anaerobic digestion sludge yielding methane. After primary treatment for removal of insoluble matter, that is grit, grease, scum, etc., and sedimentation, the resulting sludge is subjected to secondary treatment as shown in the figure. As mentioned before, the biodegradable organic matter is utilized by the bacterial cells, that is, the microorganisms, for the growth and metabolism, and in the process, huge quantity of cell mass and carbon dioxide are generated. About 50% of biodegradable carbon present in wastewater is converted into cell mass and the rest into carbon dioxide. Among the available processes, the most important process for secondary treatment is the activated sludge process as shown in the figure. It is a continuous flow flocculated growth process in which bacterial flocks, also known as activated sludge, are separated from treated effluent by a clarifier and recycled to the aeration tank to maintain a high degree of process intensity. The microbial cell matter, which is formed as a part of the waste degradation process, is kept in the aeration tank till the microorganisms reach their saturation point of growth, when the cells flocculate well to form settleable solids. These solids settle out in a settler and part of it is discarded. The bulk of the solids, that is the return sludge, is recycled to the bottom of the aeration tank and encounters fresh sewage. The return sludge and the influent sludge provide conditions for rapid degradation of organic matter. Oxidative degradation is accomplished mostly by chemoheterotropic bacteria and ciliated protozoa. Nitrification in the activated sludge process proceeds by the action of the general Nitrosomonas nitrospira. In the first step, by nitrobacter. In the second step, denitrification takes place by the action of the genera Pseudomonas micrococcus. The merits of this activated sludge process are that it has a low retention time, BOD removal is up to 95%. However, its demerits are that it has a low strength waste. Energy is required for aeration, high sludge production is there, and there is the problem of disposal of activated sludge.